Okay, let's continue with what you have been assigned in the async class. Okay, so for Friday night, since we are no longer at the Ramadan month, so I will going to do the night class online. Okay, so there will be no video assignment because I found it a bit distraction when I cannot discuss a lot, okay, during the online class. So hopefully during the night class I can cover within 1 hour so that everything will be covered according to the specified time. Okay, beginning with this Friday. Okay, for today's class, I believe some of you have already gone through few questions that I posted in the attendance sheet. Okay, so thank you very much for those who correctly answer. But since I have limited time, I'm not going to discuss at the beginning of the class, but rather I would go to the first what we call probability distribution. That will be on the discrete probability distribution. Now, based on the what we call video assignment that I have assigned you last time before the Hari Raya, okay, I believe I have outlined the learning objective that is being focused for the assigned videos. Okay, among else, the first is to identify whether a random variable is discrete or continuous. So we are going to discover that in this class. Second, define probability distribution of a random variable, differentiate between binomial and Poisson. For today, I will cover only binomial. Friday night, I will go into Poisson. Okay, because there are few concepts involved that I think I should explain. I need everyone to understand how the concept should be understood, and everyone need to know how to do it. Okay. Of course, we are going to cover this too, and the rest applying to Poisson, we are going to cover on Friday night. Okay. Now, what is discrete probability distribution? So we know that basically we are going to cover two, discrete and continuous. Okay, so continuous we know, okay, means any value on the interval. But what about discrete? Okay, let's go back to what we call a random variable. Okay, so a random variable usually written by capital letter X, Y, or Z is a variable whose value are determined by chance. Last time we discussed about X. Okay, X refers to variable in chapter 1. Okay, means that X refers to the interest of our what we call study, interest of our investigation. So if we are talking about skewer, we are talking about the length of skewer. But now in chapter 2, we are talking about X, what we call random variable. Okay, variable in chapter 2. So what is the difference between random variable and variable is actually related to each other. Okay, so random variable means that there are elements of chance in terms of the outcome of your experiment. So this is what we call random variables, where the chance goes back to the probability of a particular outcome to occur. Okay, so what is discrete random variable then? A random variable that takes only certain values along an interval means that we have exact value. What types of exact value? Beginning from 0, 1, 2, 3, etc., etc. Any exact value that we call as discrete random variable. Means that the X will take such value. Okay. What about continuous random variable? A random variable that takes a value at any point along an interval means that if you have the scale, from 0, 1, 2, until whatever number, let's say 10. It can be at any point of your interval. It could be 0.3, it could be 1.3, it could be 2.8, whatsoever. Okay, so that would be the difference between discrete and continuous. Now, when we say exact value, means that we are referring to what we call experiment with the outcome that can be an exact term. For example, okay, if you have a discrete random variable, number of sales, number of calls, share of stock, people in line, mistakes per pick. All these can be calculated exactly. Okay, there will be no 2.5 people in a line. Then there's no such thing as 2.5 people. 2 people, 3 people, 5 calls, 10 calls, whatsoever. Okay. In reverse, for continuous random variable, okay, we have length. For example, measured in centimeter, 13.1 cm, 13 cm, 12 cm. Depth, 1 meter, 2 meter, 3 meters, so on and so forth. Volume the same. Time, weight. Weight also can be in terms of 0.5, 0.7, 0.1, 0.0, whatsoever. So this will be the two types of random variables that we will have in our experiment. Now, let us focus on the discrete probability distribution. Can everyone listen to my voice, class? Class?
Yes, one. Yes,
Okay,
yes.
thank you. Okay, thank you. Now, let us go detail into how the notation, how the details of discrete random variable that we need to represent our experiment. Okay, a discrete probability distribution consists of possible values. A discrete random variable x can assume and their corresponding probability means that I have my x random variable. Okay, random variable. This x can take values. Okay, exact values 0, 1, 2, 3, 4, 5. And it also has its probability. Okay, for example, if I'm talking about x, my x is 0, 1, 2, 3. So for each x that I have in my experiment, so x is equal to x, where px is equal to 0, px is equal to 1, there will be certain probability involved. Okay, there will be corresponding probability involved. How do we calculate? We have done this before. If we are talking about flipping a coins, then we are talking about define the head as your random variable. Then your random variable referring to the number of heads appeared in your what we call experiment. The other way around, right? The other way around can also be defined as your x, depending on what is your definition of x. Now, let x be a discrete random variable and px equal to x is read as probability of x exactly equal to x. As this one lah. What is the probability of my random variable is equal to certain value, for example 2. Okay, so how do we read this? What is read as probability of x exactly equal to 2. What is that? My x is my random variable. If let's say my x is referring to the head, then it will be the number of head hitting a coin. Okay. Now, what else should I know about this discrete probability distribution is following the probability distribution that we have discussed before. What was that? The first one, probability can take from 0 to 1. So probability can take from 0 to 1. That will be the first one. Second, the summation of all the probability means that if I have 3, the summation of all these 3 is equal to 1. Cannot be more than 1, cannot be less than 1. If the summation is less than 1 or bigger than 1, then we don't call it as probability distribution function because it does not fulfill the two criteria for discrete probability distribution. Okay, so probability distribution can be in terms of table, in terms of graph, or in terms of mathematical formula. For example, this one lah, probability of x is equal to 2. Okay, what kind of table, what kind of graph, let us see. Okay, for the first one, in terms of table, as what I have mentioned just now, if we are talking about example 2.1, last time we are talking about in a family of 3 children. Okay, if we define as x, our random variable as the number of boys in a family of 3 children. Okay, so we can define this particular random variables in terms of table, and we can have this where x can be can fix value 0, 1, 2, 3. Why 3? Because we have maximum 3 children only. Okay, so for each value of x, there will be corresponding probability involved. Okay, so this one in terms of table. How about what we call graph? Usually in terms of histogram. Okay, so this is what we call as graph. Okay, so that graph will involve the number of what we define for the random variable. So in this case, x is the number of boys, and the y-axis refers to the probability involved of getting 0 boy, 1 boy, 2 boys, 3 boys. And more or less, we just transfer this table into what we call histogram. Okay, so these are the common what we call discrete probability that always being discussed in terms of concept and everything. Okay, now how many types of probability distribution that we are going to cover in this class? So we have discrete and we have continuous. For discrete, we are going to cover binomial, Poisson, and Poisson approximation of binomial. And under continuous, there will be only one that will be normal, and there will be normal approximation of binomial as Poisson. So somehow or other, these can be approximate into what we call continuous random variable. And how it is possible, we will see later. This let us look at the example of binomial probability distribution. Okay, so when we say x following binomial probability distribution, means that the x random variable occurred from a binomial experiment. Okay, so what types of binomial experiment we may have? So for example, tossing a coin is considered as binomial experiment. Baby born can be considered as binomial experiment. Football game, true false question, multiple choice question are all considered binomial. How and why? So look at the possible outcomes. For example, tossing a coin, we know there will be 2 outcomes. It's either getting the head or getting the tail. So 2 outcomes. Baby born, there will be also involving 2 gender. It's either male or female. Right? So 2 outcomes. Football games, if we want to define our x random variable, is either win or lose, then 2 outcomes as well. True false questions, of course, true and false, 2 outcomes as well. And finally, multiple choice question, and we define as correct, incorrect. So what you can see from the possible outcomes from these different types of binomial experiment, you can simplify it involve 2 possible outcomes. Right. Okay, 2 possible outcomes. Okay, now If you can still remember, one of your video, if I'm not mistaken, one of your video mentioned about Bernoulli experiment. So what's the difference between Bernoulli experiment and binomial experiment? Can someone tell me what is the difference between Bernoulli and binomial? Someone, class? Someone, please? What are the difference between Bernoulli and binomial experiment? Answer, please, answer. Don't know, say don't know. I just want to hear some voice. Oh, a voice. What is the difference between Bernoulli experiment and binomial experiment, class? Okay, anyone to try? Anyone? Are you all with me, class?
Don't know.
No, you are not with me. You don't know or what? Class? You know what I have? Okay, no, you don't know. You know what I have? My proposal defense. I was the chairman for proposal defense this morning, beginning from 10 until 12 something. Then follow with the class RK24 from 1:30 until 3:25. Then I have with you until 5:30. So I wish whenever I ask, anyone can respond to my question because I'm really exhausted. Okay. Okay. Now, what are the difference, or what is the difference between Bernoulli and binomial? In Bernoulli, it involves only one trial. But for binomial experiment, it will be many trials. How many trials? 2, 3, 4, 5, 6, 100, 1000, any number of trials, but greater than 1. So that will be the difference between Bernoulli experiment and binomial. What will be the similarity of binomial and Bernoulli? Both are having two possible outcomes. Okay, both are having two possible outcomes, but one for one trial, the other one is for many trials. Okay, because of these many trials, that's why we can approximate the Poisson and the binomial to the continuous or normal probability distribution. We are going to cover that later. Now, let's go into specific. What is binomial probability distribution? Okay, having said that, we knew some of the example for binomial experiment. Okay, class, your assessment for your quiz and for your test with regard to chapter 2 has been designed for you. So if you don't understand the concept of the whole thing that I discussed in the previous class on Wednesday last time, until this class, it will be difficult for you to answer the question in your test or in your quiz. Okay, now, how do we know that it is a binomial, and how we can check it is a binomial probability distribution? So an experiment which satisfies the following characteristic is called as binomial experiment. So how many criteria? 4 criteria. What is the first one? The random experiment consists of n identical trials. So means that the many trials that we have, that I mentioned just now, refers to the same exact trial, repetitive. Means that if you are tossing a coin 10 times, so you are tossing the coin similarly for each and every single tossing a coin. Okay, identical trial. Okay, each trial, number 2, can result in 2 outcomes. we know that discrete is about two outcomes. Yes. So the criteria for binomial probability distribution, it also has two outcomes. But now the outcome is called as success and failure. Okay, success and failure. F and S. S stands for success, F stands for failure. Okay, the third criteria, the trials are independent, means that the outcome of a trial is not affected by the outcome of any other trial. Means that if I'm tossing a coin 10 times, the first toss, the outcome of the first toss will not affect the second outcome of the second toss. On and on the same. So means that independent trial means that the outcome will not affect the outcome of the following trial. And finally, the probability of success. Remember class, binomial is always talk about probability of success. Okay, always about success. Okay, sometimes the failure also is considered as success, depending on the definition of your X random variable. Okay, so whatever defined as your random variable, that is considered as your success, even though it refers to the failure. Okay, so the probability of success, P of S, is equal to small p. Okay, so this is the probability value. Okay, and the probability of failure, is equal to the total probability of 1 minus p. You will get your p. Okay, as simple as that. So next time, whenever you need to judge whether an experiment is a binomial experiment or not, so you have to check all these four criteria. Are they met or not? Okay, if they are all met, then we can say the X random variable that we are dealing with is what we call the binomial probability distribution. Any questions so far, class?
No, madam.
No. Okay. If no, let us look at the example. Let's say we specifically discuss on how the binomial probability distribution can be illustrated in terms of its what we call notation. Okay, because the notation will be very helpful for you to solve the probability equations given to you during the assessment. Now, consider an example of a coin is flipped 10 times and you're going to count the number of hits. So from here, you have to what we call analyze. Okay, so analyze in terms of the four criteria that you have about the binomial probability distribution. In this case, we are talking about flipping a coin 10 times. So we are talking about n identical trial, 10 identical trial. So we know that flipping a coin will give you an outcome is either head or tail. So it will be the second criteria. And we know that flipping a coin from first toss to the second toss is not affecting to one another. So we know that it is an independent trial. And the probability of success in this case is what we call counting the number of hits. So probability of success is getting the number of hits in the what we call in the 10 trial. So in this case, probability of success remain constant from first trial to the 10th trial. Okay, so these are all the criteria. But in terms of what we call notation, okay, there will be the first notation referring to X, second referring to the random variable X, third referring to the probability of success, fourth referring to the probability of failure, and finally is referring to the probability of X exactly equal to some value of X. So these are all the definition of each notation. So make sure you understand whenever we say probability of success, okay? Success, okay, is referring to your PS. Whatever defined will be your probability of success. Okay? Okay. Now, so the distribution of x that follow binomial distribution is written as x curly b and p. What is this? So if I can use, okay, so x we know is the random variable, okay, the random variable x following binomial with the parameter n and p. I say these are this known as parameter. Can you still remember where you find parameter last time class? Where do you find parameter in your discussion class? Class? Are you all with me, class? What do you define parameter, class? What is parameter, class? Where do you find parameter? I'm waiting for your answer. What was that?
Is it from the box plot?
I cannot hear you. One more time, please.
Is it from the box plot?
Huh? Box plot? No. Where do you find parameter? The terms parameter before.
Population.
Yes, when you are discussing about population. And parameter refers to any measure from your population subject. And we are talking about statistic is referring to the measurement taken from your sample. So we describe this, what we call probability, what we call the distribution function of your x following binomial with n number of trial and p probability of success. We say this NP is referring to your parameter, means that your experiment is considered as your population. Okay, so that is why we call it as parameter. Now, what about this x that follow binomial? If we know our x is following binomial probability distribution with numbers of trial n and probability of success p, then I can find the probability of this x equal to some value of x using this particular formula. As easy as that. For example, if I want to find px is equal to 2, okay, then I can use my formula here. Let's say my n is equal to 10. So 10 C2 P to the power of 2 Q to the power of 10 minus 2, that would be 8. Plug in all the value of P and Q and you can find your probability value where X is equal to, as simple as that. Okay, or you can I think I believe everyone understood this. Okay, when we say n combination of x, ncx is obtained by using this formula. But if you just can simply use your calculator to find ncx in your calculator. Okay, so everything has been simplified for you. Now, when we talk about x random variable, we know that x can be following binomial, and there will be definitely ways on finding what will be the mean, what will be the variance, and what will be the standard deviation of your x random variable. So how do we find the mean, variance, and standard deviation of my x that follow binomial? Okay, so my mean can be obtained by multiplying the number of trials with the probability of success. As simple as that. What about my variance? My variance can be obtained by multiplying the number of trials, probability of success, and probability of failure. That will give you variance. And square root of NPQ will give you your standard deviation. Okay, sometimes we may ask, what will be the mean of the particular experiment that given to you? So you should know how to find the mean, variance, and standard deviation. Next, now, okay, mathematical symbols. Why is it there? So if you look at your page on 47 of your textbook, okay, you have mathematical symbols in table 2.3. Okay, why do we need this? Okay, class, go back to my few examples just now. For example, this one. Okay, if let's say I put this table in the page where I discussed, okay, so that you can easily refer to this. Now, if let's say we are talking about, let's say we're talking, I'm really sorry because I'm actually sitting on my katil so tak ada kursi sebab anak semua ada online learning kat luar, so saya terpaksa buat dalam bilik. Okay, now let's say you have 10 trials, okay, and if I put the trial as well as the corresponding probability this way, okay, so these are all the x value that can take place from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we know that for every single x value, there will be its corresponding probability, where px can take any value above. So for example, if let's say for x is equal to 0, there will be its probability. The same here. Okay, the same. For example, if I write this, so this is what we call px is equal to 1. This one is px is equal to 2. This one is px is equal to 3, is equal to 4, sorry. And this one is px is equal to 10. So there will be its specific probability value. Okay, so definitely there will be values here, probability values involved. Now, why do we need this mathematical symbol? Because this one. If you are being asked about find the probability of x is equal to 2, it is easy, right? You can use the formula and cx, p to the power of fx, q to the power of n minus x. Definitely you can get the probability value. Okay, now what if the question asks you about px less than or equal to 2? What does it mean? What does it mean? You have to know what is the difference between, okay, you have this and you have this. If x is equal to 2, you are talking about specifically 2. If you are talking about x less than or equal to 2, means that you are talking about all this probability function. Means that you are talking about px is equal to 0 plus px is equal to 1 plus px is equal to 3. Sorry, 2. Okay, equal to 2. See the difference between equal to 2, less than 2. What if you have given another equation which involves more or bigger number, bigger value? For example, px less, because we have 10, you can be asked maybe find the x less than 9. So how are you going to find the probability? If this is the case, then you can just plug in the formula, you can get the value of the probability. What if less than 9? Means that you need to find the px equal to 0 plus px equal to 1 until not
Until 8,
including
right?
9. That
Px equals
px
to 8.
less than or equal to 8 because 9 is not included. Okay, so these are all the things that happen behind the concept of this. Okay, which you need to understand. Okay, now because sometimes the question will be asked not directly. We are not going to give you this directly in your questions. Your question be given to you in terms of this one. Imagine if you have this. Define the random variable x and its distribution. Okay lah. What is the probability exactly for? Okay lah, because we know that this is referring to px is equal to 4. What if fewer than 4? Px less than 4. What about more than 4? Px greater than 4. How are we going to do the calculation? Easy way. Okay, so this gives you the way on how you can do it easily. Okay, understanding the given terms in your question. What are the terms given? Okay, for example, the first term greater than or equal to, or sometimes used as at least, or sometimes not less than. So what are the notation for all these three phrases? Is greater than or equal to. Next, more than or greater than or exceeds. Then this one is easy because it does not involve the equality. So just greater than. What about fewer than or less than or below than? It refers to less than. Easy. Less than or equal to or at most or not more than. So it is less than or equal to. Okay, equal to, that is easy lah, straightforward. But what if it defines between two values? How do we know which values included or which values are not included in your probability calculation? For example, from x1 to x2, what does it mean? It means that x takes value from 1 and takes value until x2, where x2 and x1 is included in your calculation. What about between n? Between x1 and x2 means that both are not included in your phrase. Between x1, 2. So 2 here. So 2 means included. Between means not included. So you will have the term x is greater than x1. X is less than or equal to x2. For example, if you are talking about p between 1 to 3, so x less than or equal to 5. Okay, 5 is included, but 1 is not included. Greater than 1 means that it is greater or equal to 2. So that will be the understanding that you should have in your mind whenever you see all the terms. And finally, from x1 and x2, so you will have from is included. That's why we have equality in the terms. And x2, where x2 is not included. Now, these are the basic phrases that you need to understand. Okay, now, let's move. Okay, now we are talking about cumulative for binomial probability distribution. We have this cumulative. What does cumulative mean? Means that if you are talking about px equal to 0 plus px equal to 1 plus px equal to 2. So this is what we call cumulative. We add all the probability values. Okay, cumulative. Okay, now when the trial is largely large, is relatively large, sorry, table of binomial are open. Imagine if your n is equal to 100. How are you going to do that? We can't afford to calculate one by one using the table or using the formula. It is impossible for us to calculate. Now, what happened is that statistician has come up with what we call the cumulative of binomial probability distribution. Can you all go to your textbook? Okay, go to the back of your textbook. Okay, turn to page 197. Okay, 197. Everyone has got your page open, class?
Yes, ma'am.
Okay, now you can see that the table says about cumulative binomial probabilities for P is equal to 0.01 to P is equal to 0.09. So if you look at your table, somewhere you can see the cumulative binomial probability distribution. You can see the probability of success given in your first row, and you can see the terms for the formula given to you. Okay, so if this is referring to what we have discussed just now, if I'm saying about px less than or equal to 2, means that this is the summation of px equal to 0 plus px equal to 1 plus px equal to 2. See, this is what we call as cumulative. Okay, so if you look here, okay, there is a letter N, you have K, you have P. So this column reflect your trial. This K reflect your small x. This P is probability of success. Okay, so this is how we refer to the table. So statistician has come up with this particular table. Okay, so for whatever probability of success from as small as 0.1 until 0.05, 0.5, or in your textbook begin with 0.01 actually. Okay, until 0.05, you can just look at your binomial table in order for you to calculate the probability. But there are few things that you need to understand about this particular table. Now, let us go back to the things that we discussed just now. So whenever it involves larger number of trials, definitely you need your binomial table to help you out in order to find the probability value. Now, let's see. For flipping a coin for 10 trials, so you have your n equal to 10 and find without using table of binomial what is probability of x is equal to 2 and so on and so forth. Okay, so you can use your what we call your understanding using this formula. Okay, so if it is x is equal to 2, then exactly it is using your what we call 10 C2 0.5 to the power of 2, 0.5 to the power of 8, for example. Equal to 9, then it would be easy. 10 C9 0.5 to the power of 9, 0.5 to the power of 1. Then you can find the answer. What about less than 2? Okay, easy. Px, because less than 2 means that any values that takes from 0, 1, 0 and 1, because less than 2. So px is equal to 0 plus px is equal to 1. Okay, to fulfill the less than 2. What about less than 4? So less than 4 means that px equal to 0 plus px equal to 1 plus px is equal to 2 plus px is equal to 3 plus px is equal to 4. And you do it one by one using the formula. You solve for this each and every terms you have. That if you are using your formula. The same goes to 10 lah. So you can list out all the probability from 0 until 10. Now, what if we want to use the what we call binomial table? So there will be what we call terms that you need to understand in terms of redirecting the terms for the probability you are looking for. For example, okay, for example, let's see, for example, okay, now, let's see, exactly, now, before I can go to this, we know that just now, for this one, for 10 number of trial, okay, if let's say, when we say cumulative probability distribution, when we say k is equal to 2, so we have this. So for the probability of success is 0.5. What is the probability value? So 2, and you will get this. So this is what? This is what we call probability of x less than or equal to 2. What about this one? This one is probability of x less than or equal to 1. Okay, what about this one? This one is probability of x less than or equal to 3. And what about this one? This one is probability of x less than or equal to 10. So means that probability of x less than or equal to 10 is actually the summation of all the probability from 0, x is equal to 2, until the last one is px okay, px less than x is equal to 10. Okay, that's why you got 1. This is the summation of all the value that you have in your trial. Okay, so when you want to use the table of binomial, one thing you have to make sure all the symbol or the sign is less than or equal to. Must be this way before you can refer to the table. But somehow your equation will be in terms of this one. Okay, in terms of this one. So your equation can be written as this one. So that's why you need to understand what does px is equal to means. What does px less than x mean? What does px greater than x means? Okay. Now, if let's say we are talking about from 0 trial, from 0 trial, 1 trial, 2 trial, 3, 4, 5, 6, 7, 8, 9, 10 trial. Okay, when we say px is equal to x, for example, px is equal to 2, means that we are talking about definitely at this particular value. Okay, at this value. Okay, means that if I were to note down the place, it will be including 2 only. Okay, so what about if I have less than x? Px less than 2. What does that mean? It means, okay, let's say I use my blue pen here. So blue pen, px less than 2 means that it is px, as I mentioned just now, x is equal to 0 plus px equal to, what was that? 1. Okay, we stop at 1. Okay, or we can say px is less than or equal to 1. Okay, So this is what it meant by if you have this will be the phrase that you are looking for. If you have this will be the things that you are looking for. If you have this question, this is how you find the value of your probability. So, for example, if you are talking about Px greater than 3, for example, where 3 is here. But is 3 included? No, 3 is not included, means that we are talking about Px less than greater or equal to 4. So these are the areas that we are looking for. But how we can transform this into using this symbol? So this will be the total probability is all 1. So that's why, having said we want to find this area, it will be 1 minus probability of x less than or equal to 3. So that's why we have this. Okay, this understanding. The same goes to if Px greater or equal to 3. Now 3 is included. Okay, so it will be 1 minus Px less than or equal. Since 3 is included, so we are talking about 2 and below. Okay. The same goes to if included, so what will be the terms used? If not included, what will be the term used? So these are all the concepts that you need to understand. Okay. I hope I don't give you more headache on how actually this will be simplify your process of finding the probability. Okay, let us look at the actual calculation if we have these particular questions. Okay, let's say you have the same what we call example as I mentioned just now. Okay, you have a coin with toss for 10 times, and you are saying that the x random variable is the number of what we call getting the heads out of 10 times tossing. Okay, by checking the binomial criteria, everything fulfilled. So we know we are talking about binomial probability distribution, and we can define the x random variable as the number of getting head when tossing 10 times. Okay, and the distribution of your x following binomial is written as this one. Okay, so far, do you have any questions, class? Any question, class? Yes. Yes. I heard only doctor. No doctor, or do you have any question?
Oh, no.
Okay, no question. Okay, thank you. Now, let us begin on how we can use the binomial table in finding the probability distribution. So, this means, class, for any calculation of finding the probability for binomial probability distribution, I'm assuming if you want to use your formula, there will be no problem. It's just a matter of you need to understand this concept. Okay, this concept. If you are using your what we call formula directly. But now, since we may have bigger number of trials, we can afford to check one by one, to calculate one by one. So let us see how the table helps us out in finding the probability value for the trials that we have. Okay. Now let's say we know that the distribution is given as this one. Okay. You need to find the probability of x. Okay. Find the probability of x is equal to 2. We know that cumulatively, if you are talking about 2, these are the cumulative, means that Px equal to 0 plus Px is equal to 1 plus Px is equal to 2. But now I need to find only for 2. So using the probability distribution function cumulative, so it will be Px less than 2 minus Px less than or equal to 1. Why? Because this one, look at this one minus this one will give you Tx equal to 2. Okay, so that's why from the table you can find directly less than or equal to 2 is 0.0547 minus 0.0107. Can someone calculate for me? What is the value here? Plus 0.044. Is it? Now let us check. What if we use the formula? Px is equal to 2, then C2 0.5 to the power of 2, 0.5 to the power of 8. Can someone calculate that using your calculator? You can use your NCR is above your division form. So 10 is 2 times what do you get, class? You will get what? 0.0439, right? If we approximate, it will be 0.44. Okay, 0.44. If let's say 3 decimal point. Is it correct, class? Class? Hello? Any comment here? Huh? What was that? Okay, not okay. Okay, yeah? So if you are using your table, okay, if you are using your table, this is how you can solve it. If you are using your formula, this is the way you solve it. Now, the second question, Px less than or equal to 4. So how do we find that? Exactly from your okay, we are looking for probability of success 0.5, number of trial 10, and we are looking for less than or equal to 4, meaning that it is directly from your distribution table. So looking for 4, so this will be your answer directly. So 0.3770. Done. So if you use your calculate your formula, so you will have to find for Px is equal to 0 plus Px is equal to 1, Px is equal to 2, Px is equal to 3, Px is equal to 4. So you have to find 5 probability distribution for each x is equal to 0 until x is equal to 4. What if I have less than 3? Ask yourself, is 3 included? No, 3 is not included. Since we are using this term, class, and remember, we are using this less than or equal to because this reflect from your what we call number of x that we are referring to. So if x less than 3 means that it is Px less than or equal to 2 because 3 is not included. So you can directly check from your table. For 2, directly it is 0.0547. Right. Okay. Any questions so far, class? Any question? Kalau tak ada, siapa jawab tu tak ada lah tu. Now, what if we have greater than 3? Okay. So if I have 2, 3, 4. Now, we are talking about 3. But 3 is not included. Means that greater or equal to 4. So it means that it will be 1 minus px less than or equal to 3. Because 4 is included. The whole is 1. So we are looking for this. Okay, sorry. This is considered 4. Okay. So we are putting the description is not including 3 means 4 and above, so it will be 3 and below. Okay, this will be the area that we are looking for. Okay, so easily from this, once we have transformed this into the equality that follow the binomial table, so we'll have 1 minus px less than or equal to 3, which is 0.1719. So you will get what here? Can someone calculate for me? Do what?
0.8281.
Okay, thank you. Correct. So see, it would be easy if you can transform based on your understanding now. We are talking about 5, 6, 7. Now, greater than 6, and now 6 is included. Okay, so it means that it would be 1 minus px less than or equal to 5. Okay, less than or equal to 5. Right. Greater or equal to. Okay, so it would be minus 1. Okay, so it would be 1 minus 5 will be 0.6230. Can you give me the answer here? 1 minus 0.6230. So okay, right. Okay, I hope everyone can get the rhythm of how we can transform into the cumulative probability distribution for the binomial. Now, we are talking about 4, 5, 6, 7. 4 and 7 is included. Okay, greater than, less than or equal to 7 means that the whole thing from 0, okay, minus 4 also included. So how will it be? So it will be px less than or equal to 7 minus px less than or equal to 3. Should be minus 1 at the back. Okay, minus 1. So the x1 need to be minus 1. Okay, so you can just use your table for less than or equal to 7. 0.9453 minus 3, that would be 0.1719. So what is the value here?
0.7734.
7734.
4.
Okay, thank you. Now, what about if I have 4 until 7, but both are not included? Greater than 4 means that we are talking about 5. Less than 7, we are talking about 6. Okay, so if we are talking about less than 7, the whole thing about less than 7 minus less than greater than 4. Okay, so we can transform that into px less than or equal to also forget. Okay, it will be the beginning will be minus 1. Okay, so it would be 6 minus px less than or equal to 4. So that will be 0.8281 minus less than or equal to 4, 0.3770. Okay, what is the value here?
0.4511.
0.15.
4511. 4511. 4511.
Okay, 4511. Okay, thank you. Done. Okay, so the only thing you need to ensure that you understand this term. Okay, it will help you out in terms of how to transform into the terms that fulfill the cumulative probability distribution function for the binomial. Okay, now let's look at the second example. A large industry firms allow a discount on any invoice that is paid within 30 days. Okay, so this is your hint. Okay, any invoice submitted within 30 days will deserve 10% discount. Okay, of all invoices, 10% receive discount. So what is this? Okay, 30 days is about the invoice given back to the company. In the company audit, 12 invoices are randomly selected and independent of each other. So independent of each other, it gives you a hint of that this is the number of trials that we are looking for that involved in the experiment. Okay. I have problem with my extension. Sometimes just randomly disappear. Now, how do I begin with this particular what we call notification of how to simplify everything? Okay, define the random variable x and write its distribution. Okay, so your x, okay, is defined as what? The number of, because always the number, binomial always equal to the number. The number of what? The number of invoices okay. The number of invoices in the 12 sample receive discount. Okay, 10% discount. So that will be your X. Okay, knowing the information given from your what we call questions, we know that this is dealing with probability, because probability is either in a fraction, in a percentage, okay, usually in percentage or fraction. And this will be the number of trials, that will be your N. So X can be written as following binomial with number of trials 12 and the number of what we call probability of success. What is the success? Getting the discount. So that will be 0.10. Okay. This will be the first question asked when you have such question related to probability distribution. So the first thing you need to identify is what will be your X random variable defined as, and the second, how your X random variable following certain probability distribution. Okay, now let us go to the second question. What is the probability exactly for in the sample of 12 receive discount? So means that out of 12 invoices, exactly 4. Okay, exactly 4 receive discount. Okay, so P, question number 2, probability of X exactly 4 means that exactly 4 invoices receive 10% discount. What is the probability? So as we know, as what we have discussed before, this one refers to the cumulative from X is from 0 until X is equal to 4 cumulatively. So we need to find the exact value for 4, means that we have to X less than or equal to 4 minus Px less than or equal to 3. Okay, the number, the value before it, because the value before this is actually from X is equal to 0 until X is equal to, okay, so this one is from X is equal to 0 until X is equal to 4. So you know 4 minus 3, you get exactly at 4. Okay, so from your table for 12 number of trial, probability of success, sorry, not here. Probability of success is 0.1. Okay, so we have 0.9957 minus 0.9744. What is the value here, class? Can someone give me? Zero 0.9957 minus 0.9744. What is the value?
0.0213.
0.0213.
213. 213. 213.
213. In your textbook, the example for this is using the binomial from Excel, right? Okay, from Excel. So from Excel, what happens is that you can find the function of binomial and you can put the number of trial and you can put the number of the probability of success and you can find exact probability value. So that's what happened on page 50. So you have what we call the X here and you have the X equal to X from 0, 1, 2, 3, 4 until 12. Okay, what happened is that using your Excel, you can find your probability value for exactly X is equal to 0, which is using the function you get 0.2824. Okay, then exactly 1, X is equal to 1. This is actually the same as using 12C0, 0.1 to the power of 0, 0.1, 0.9 to the power of 12. Okay, so for the second one is 0.3766. So this one is actually using the 12C, if you are using the calculation, 12C1, 0.1 to the power of 1, 0.9 to the power of 11. So if you using the Excel, then X is equal to 2, it will be 0.2301, which is the same as our answer. Sorry, 4. This one is 4. And referring to 4. Okay. If you're referring to the 4, Px is equal to 4, definitely it gives you 0.213, which is exactly the same as what we get if you are using the cumulative binomial probabilities. Clear or not, class? Okay, class?
Madam,
What was that?
Can I know why yang tu 0.9 lah bukan 0.1? The calculation. I thought should be the same.
Yang mana? Yang mana?
Yang
Nombor
12 C0, 0.1 power with 0, then 0.9 power of 12. Why is it 0.9?
This one is probability of success. This one is probability of failure. Kan dekat formula, sorry. If you go back to your formula, what does your formula says? The formula says NCX PQ. What is P? Probability of success. What is Q? Q is actually 1 minus P. That is your probability of failure. So don't mix up with failure and success with the power, because it reflects your answer at the end of the process. So please make sure everything is correct. So if I refer back to the Excel, okay, clear? Okay. So if you go back to your x is equal to 12, you will get 0. And actually, if you add this, the total will give you 1. That's why for 12 trial, what is your cumulative? Is 1. Because this 12 refers to Px is equal to 0 plus Px is equal to 1 until the last one, Px is equal to 12. Okay, that's how Excel get 1 and how the cumulative table using the table of binomial get 1. So you understand the concept of cumulative and you understand the concept of adding all the probability will give you 1. Okay, I hope this angle can be understood by every one of you. Okay, now let's move to the second question. The second question asks, the third question, sorry, fewer than 4. Fewer than 4. Okay, the third question, fewer than 4. Px fewer than 4 means that 4 is not included. So if we go back to the scale, if less than 4, what is the nearest one? Is 3. So means that 3 and below will be included. So definitely it's Px less than or equal to 3, which is using your table. So it will be 0.9744 directly from your table. What about question number 4? Okay, so if you look at your textbook, okay, on page 50 for question number 3, the textbook is using the calculation of formula. So we get the same answer as what obtained if you are using your formula on page 50. Okay, you can enter that. What about question number 4? Question number 4 says probability at most. What is at most? At most, I forgot lah. At most, okay. What is at most? At most, less than or equal to. Okay, less than or equal to. P x less than or equal to 4. Yes, 4. So directly, it is from your table. So it is 0.9957. So if you go to your textbook, okay, if you are using your calculation of formula, okay, you get almost the same lah, 0.9956. Considered the same lah. Okay. I hope everyone understood. Okay, after number 4, number 5. Number 5 says about at least more than 4 invoices, sorry. More than 4. So X greater than 4. If we are referring to the scale, 4, 5. More than 4, but 4 is not included, means that 5 and above. So it would be 1 minus Px less than or equal to 4. Because 5 is included in your calculation. So 1, the whole probability, minus the one that perfect. So it will be 1 minus x equal to less than or equal to 4. So 1 less than or equal to 4 we have obtained is 0.9957. So if you deduct this, you will get, okay, it will be 0.0043, right?
Yes.
Okay. Any questions so far, class? That is question number 5, number 6, and number 7. Okay, last, number 6. If P number 6 is at least 4, at least 4 is noted as x greater or equal to 4. Means that if I have 4 here, okay, 5 here, so 4 is included. So means that I will have 1 minus Px less than or equal to 3. Okay, so that will be 1 minus 0.9744. And this will give you 0.0257.
6.
Right. 57, right? 257. Okay. Now, last question. Find the, okay, what can we explain about all the value of probability? Okay, for example, less than 4 means that what is the probability of out of 12 invoices, less than 4 means that 3 and below 3 invoices will get discount. What is the probability? High probability means that 97% will get the probability. Okay, that is the referring to the probability of getting the discount if the number of success is 3. Okay, what about greater than 4? What is the probability of more than 4 invoices get the discount? Lower chance, 0.0257, or we can say as 2 times 100, 2.57% probability more than 4 invoices will get this. But less than 3, higher chance. More than 4, lower chance. So that's how we interpret the probability value. Last but not least is number 7. Number 7 asks about the mean, variance, okay, and the standard deviation. So simply means is obtained by NP. So what is my N? 12. What is my P? 0.1. So it will give you 1.2. What is my variance? Sigma squared NPQ. So 12, 0.1, 0.9. So this will give you 1.08. Okay. What is your standard deviation? NPQ. It will give you 1.04. So how can we interpret this mean? Okay. For the process of selecting 12 random invoices randomly, selecting 12 invoices randomly, the mean number of invoices received discount is 1.2 or 2 invoices. It takes the approximation larger than if you get, usually if we have 1.5, we say what we call 2. But in the case of this particular case, if you have more than 1, for example 1.2, we consider, okay, in average. Okay, so the mean number of invoices receiving discount is 2 out of 12 invoices. Okay, any questions so far, class? So far, I have covered the most important concept that all of you need to understand. The class, the things that I highlight in yellow in terms of how it become the next part. Okay, for example, this to this. Okay, this to this. Okay, it will be repeated in your what we call Poisson as well as in your continuous probability distribution. So you need to understand the whole concept of this one. Okay, you need to understand the concept of this one. Okay, the same with this one. Okay, because remember all the condition will be given in terms of sentences. We will not going to simplify to you in terms of notation because we measure how students understand in order to transform from sentences to mathematical notation as part of the curriculum in engineering statistics. So it is good for you to, if you don't really clear, please look, go back and look again the video, the teaching video, so that you can understand the whole concept. Or if else, you can find other video, short video that can simplify the way you understand the concept. Okay. Do you have any questions so far, class? Do you have any question, class? No, huh? So let me stop sharing, stop recording.